Who is there in NPTEL? Queen or someone else?
Myself, Injamul Haq.
Sorry?
Injamul Haq.
Okay, Injamul. So there are only 3 learners over here.
Yes, sir.
So shall I begin?
Yes, sir. You can start.
Okay. So welcome, others. I mean, Arun, Bablu, and Prince. Welcome to this session. So if you have any queries, please ask. Bablu, I get emails from you, and I replied also. I hope you have got the reply.
Yes, sir, I have got the reply and solved the problems also, and all are correct.
Okay, great. And Prince, probably you have asked me some question here. As far as I remember, just let me check what question you have asked. Open the email. Okay. So Prince, you have asked me something about residual curve, NPSH of pump, and surging in compression. So can you please tell me what exactly is your query? Let's share it. Yeah. Yeah. So Prince, your question is residue curve, NPSH of pump and surging in compression. Now, what is the question actually? You have given 3 topics, and I don't know what exactly question is. The next question, I don't know whether the person is over here, SSK Verma and Abhishek. No. SSK Verma asked, what is the pattern of final exam, whether it is simulation based or theoretical based? Well, final exam will be only theoretical based. So you don't have to do any simulation. In fact, you do not have any means to do simulation because you have to go someplace and then write the exam. And there you do not have the access of the software. So it will be completely theory based. And you might have noticed that in the assignment section, there are 2 sections in any assignment. There is part A and part B. So in the part A, in order to answer the questions in part A, you do not need the software. You can answer the questions based on the information that is given in the question paper without accessing the software. But part B, you have to have the software and you have to perform the simulation, and then only you will get the answer. So in the final exam, all the questions will be in the pattern of part A, not part B. So you don't need any simulation software. All the information will be given in the question paper. You have to answer from there. And third question, Abhishek, sir, what type of question to be asked in exam? So I have already answered you. So except Prince Patel's question, Prince Patel actually he didn't ask any question. He has given 3 topics. So I don't know what is his doubt. So Prince Patel is here, but he is not saying anything. Prince, are you trying to communicate? Because I am not able to listen anything from your side. Prince, you are mute, Prince. You are mute. So you have to open this mute button. You have to unmute yourself. Okay, now you have to tell something. Okay, if he is not able to communicate, then probably others like Arun, Pablo, there are 2 Aruns, I think. Singh and Arun Shilash.
Hello, sir. I'm audible.
Yes, Prince, now you're audible. Tell me.
So, sir, can you just tell me the basic concept behind the topic which I have given to you?
Basic concept means you mean to say you want to understand the residue curve, NPSH, and surging.
Yes, sir.
These are the things that you have learned during your chemical engineering. All of them are in chemical engineering textbook. NPSH of pump you will learn in your fluid mechanics. I can explain this because I have time right now, but these are not the things that you will expect to be discussed in this forum, because this forum, um, it is expected that you will know the basics and you will be learning the use of Aspen Plus software. So I will expect you will know these things. Anyway, I will tell 2 things, not all 3.
Okay, sir.
Okay. Okay, for the timing, let us discuss the residue curve. Okay, residue curve is something like suppose there are tertiary mixture. This is suppose you have the highest volatile component over here, and this is the lowest volatile component over here, and this is intermediate volatile component. So as the uh, liquid and gas or liquid and vapor, as you increase the temperature, then obviously the liquid will move to the vapor phase, right? So the composition of all 3, say A, B, and C. So composition of A, B, C in liquid and composition of A, B, C in vapor phase will change, right? So suppose in the very beginning um, you have high amount of, in liquid phase you have high amount of um, high amount of all of them. Okay. So as you increase the temperature, as the components start moving from liquid to vapor, initially the lowest, the highest volatile component will move first. Okay, so after some time it will be somewhere here, because initially this will be the highest position, because A will be there in liquid phase. But as you increase the temperature, the mole fraction of A will reduce. Okay, and when at the last drop of liquid, the composition will be here, because the last drop of liquid will have entirely C. There will be no A and no B. So it will begin from here and end here. Okay, so the trajectory of the point will move like this and this. So this will be the trajectory. So this curve is called the residue curve. Residue means whatever is there in the liquid phase. If this is the liquid phase and this is the vapor phase, so residue is whatever is there in the liquid phase. So composition of components in the liquid phase. So that is the residue. So residue curve means as it goes from liquid to vapor, how the composition changes in the tertiary phase. So that is called the residue curve. And NPSH is net positive suction head. Okay. And this is so common that you shouldn't ask this question over here. So if you do not know, you just you refer to any fluid mechanics book where you can learn about pump, and one of the basic concept of pump is net positive suction. So you will understand. Surging in the compression, well, I mean, in any compressor where there is a axial movement, sometimes the compression will not be smooth. I mean, we would expect that the axial movement will be smooth and then it will come back smoothly and then it will move, something like this. So the piston should move smoothly and come back smoothly. So that should be the ideal compressor operation. But sometimes knocking happens, that the piston that moves very fast and comes back intermediate. So there will be something like this. So it will be some movement will be something like this, and that movement will make some sound, or it is a knocking sound. Okay, so this knocking sound will be heard from outside the compressor. So that we call surging. Okay, so surging can be positive, surging can be negative. So that's exactly what surging is. It is non-smoothness of operation of any compressor. So for details, again, you refer to fluid mechanics book. Okay. Is there anyone other than them? Okay, no, only 5 of you. Okay, Arun is asking, good afternoon, sir. I am Arun. I am presently. Okay. Let me see. Chat. Chat. Okay. Good afternoon, sir. I am Arun. I am presently in Kuwait working as DCS operator. Well, Mr. Arun, if you are working as a DCS operator in a refinery, then I believe good afternoon, sir. I am Arun. I am presently in Kuwait working as a DCS operator in a refinery. I completed my BTech in 2012. I have forgotten much of the theory, but I am able to follow your lectures and understand properly. Presently, I'm trying to solve as much problem as possible. Do you suggest any learning method apart from this lecture series? Also, can you give any suggestion for continuing the studies even after the lecture series is over? Is there any chance for HLC? You have 3 or 4 questions. First of all, do you suggest any learning method apart from this lecture series? Okay. Well, you will learn more by practice rather than this lecture series. Okay. I don't mind even if you do not attend the lecture series, but you should do a lot of practice. Okay. So practice makes one perfect. So only bottleneck is that you have to have Aspen with you, because in as far as this session is concerned, or this after October, when your exam will be over, immediately after that, this license will not be accessible to you. So you have only up to 24th October or something like that. I forgot the date of your exam. It may not be true. You don't get this date. So whatever is the exam date, after that, this license will be inactive for you. So you'll not be able to use Aspen through this channel. So you have to have Aspen in your respective school, or as you are working in a refinery. I do not know whether Aspen is there in your refinery in Kuwait. So if you have, then definitely you can use, and that is the only way you can learn. To begin with, you can take some problem from your refinery, and there, I mean, petrochemical problems are more interesting than any other problem. So probably you can check the layout of your refinery. Probably you will have several distillation column at different places. So and those distillation columns will be, they will be connected. There will be lot of recycle loops here and there. There will be lot of pumps. Okay, and there will be lot of exchangers. So what you can do, you can take the layout of your refinery section, and then you can do it in Aspen. The same thing, you can do it in Aspen, and check the reproducibility of the results. Suppose whatever the output you get from this end, whether it matches with your Aspen data or Aspen simulation output, that you can check. And if you get the result correctly, or if it is somewhat, will not expect exact result. There will be a lot of assumptions in Aspen Plus. There will be a lot of losses over here. In Aspen, you will probably assume there will be pressure drop of this much over here, pressure drop of this much over here. They may not be accurate in the real life situation. So those variations will always be there. Apart from that, you really do not, I mean, those things you can practice, okay? Or you can, if you get some other problem from the internet or some other books, then you can try to solve them. When I learned Aspen 20 years back, then Aspen was also not this advanced. It was okay. So I started getting the problems, simple problems from the chemical engineering books like Treble or Richardson Coulson. Whatever the problems I would get from there, I try to solve in Aspen Plus, just to see whether I get the result. Okay, so that is the way you can learn. And then second question is, also, can you give me any suggestion for continuing the studies even after the lecture series is over? I have already answered it. Is there any chance for Aspen lecture series for Aspen HiSys? Yes, I do have some plan for Aspen HiSys, but not now. I will first do the advanced version of Aspen Plus because right now probably you have seen that I have done the Aspen up to this portion. So I have, so I have discussed mixer, splitter, separator, exchanger, column, reactor, pressure changers, but this portion I have not covered in this lecture series. So I will first make an advanced Aspen Plus soft lecture series where these will be mostly taught. And once this is over, then I will go to Aspen HiSys. So that will take time. Definitely I'll do. I have some plans, but for that, obviously, the person or the NPTEL should agree. I mean, it's not that I propose something and they agree. It is not like that. So they should agree to this proposal of floating Aspen HiSys. If they agree, then I will definitely do. Then Arun Singh is asking, sir, is there any chance of uploading the assignment solution? Assignment solution, I mean, for the part A, there is nothing to upload because part A are pretty straightforward. So the solution is the answer, but what else the solution? But part B, I can at the most upload the BKP file of the correct procedure. But that is not necessary, I believe. If you have any doubt over the correctness of the solution, or if you want to challenge the solution, you can always, you can ask me, because there are many people who send me their BKP file. Whoever has any problem with the solution, I mean, I think Pablo Chauhan also sent, and some other person also sent me. I asked them to send their BKP file, dot backup file, and then I run them, and then I can definitely point out the mistake that they are doing. Okay, so that can be done for you too. I mean, if you have any doubt over a solution, you can send me the BKP file. I will try to help you out. Our tutors are informed that Professor Sir will be giving the solution. Yeah, that's what I explained. While solving the problems, I am unable to determine whether I am doing correct or right and what mistakes I have made. That's what I'm saying. I mean, you can send me the BKP file. If you see that your solution is not, your answers are not matching with the answers I have given, that is about the part B I am talking. So then definitely you can send me the BKP file and then I will point out the mistake. Or you can ask me to share your BKP, my BKP file. That also I can do, no problem. Some of the answers are matched correctly and some of them are wrong. Is there any chance? Yeah, I have answered your question. She said, okay, sir. Sir, in the last question of assignment 5, the range of answer is very less. I think it is, while other answers have high range. Can you look it? Because my answer, if I have given the narrow range, that means the probability of correct answer, getting a wrong, probability of doing a mistake is very high. Because if you, I mean, it is not a, I mean, as I have said, that it is, I want the accuracy up to 3 digits of decimal after decimal point, 3 digits after decimal point. So if your answer is correct, or if you have done it correctly, then you definitely will get an answer between them. Okay, between 2.75 and 2.77. So if you are getting 2.511, definitely you have done something wrong, which is not to be done. And the range of answer, as you said, 5 to 10, it depends upon the problem. Whichever problem I get, I mean, it depends upon that. Imam Hussein is trying to say something. Yes, Imam? Are you trying to communicate with us? Sorry, he is not talking. Arun P. Sudarshan is again saying, sir, is it necessary to do refinery simulation in Aspen HYSYS? What is the difference between Aspen Plus and HYSYS simulation? Okay, Aspen Plus is a steady state simulation software. You cannot, I mean, yeah, you can do Aspen Plus Dynamics, but Aspen Plus Dynamics is not comprehensive. So for Aspen, for dynamic simulation, you will definitely need Aspen HYSYS. That is more comprehensive. So yes, and Aspen Plus is one software, Aspen HYSYS is another. So you really, if you want, you can learn Aspen HYSYS without waiting for this lecture series. But definitely, both are useful. Sir, can you please share the BKP file so I can find my mistake and learn from my mistake? If again I'll do. Okay, I'll do. But whoever wants the BKP file, you have to write to me. I do not want to make it, public, because not everyone is interested. So whoever is interested, they should write to me. Okay, that should be the way I will communicate. And Bablu Chauhan, is there shortcut like undo and redo, etc.? No, there is no shortcut like that. In your lectures, I have observed tools pop up hovering over Aspen. Oh, what kind of tools, W?
Hi, sir. Babluchan here.
Yes.
Sir, actually, I observed that you are using the tools pop-up, which is over your screen to do back some flow sheets, undo or reduce some flow sheets. So how is it in Aspen or is it a different tool?
I did get you. What kind of tool? I mean, back or forth?
Hello.
Uh-huh.
Yes, sir.
Bablu.
There, yes. Am I audible?
Yes, you are audible.
Yes. I have seen you in your lecture that you are using some tools which is hovering over the Aspen to back the flow seats and other seats to jump over the other seats. So how you are using that?
Jump over the other sheets.
Currently it is open. Currently it is open in your screen also.
Right.
I can see
this one. This one.
Yes, this one. You have used this arrow icon left and right below two icons. Yes, this type of you have used.
Oh, this is another software. I mean, this has nothing to do with. This has nothing to do. Oh, okay. This is nothing to do with Aspen.
And I am.
This is this software called, I think this is Stored Soft Tin Ink Tree. Okay. Yeah.
Okay. And also, I am keen to know the shortcuts in Aspen where I can do my fast work. Is there any shortcuts?
Shortcuts for what?
Shortcuts in Aspen, like Excel sheet, we have the shortcuts to cut, paste, jump back, to reduce. These all the things. Do you have in Aspen?
No,
like that shortcuts?
No, nothing like that. Nothing.
Okay. And also, there is one more question. I am unable to use the duplicate term in the input flow stream.
Yeah. It is
So how you placed that
okay.
and connected the inputs? I am unable to do that.
Yes. Suppose you have this. Okay, for that you have some, say, water. Okay. So you have only water. So you go to simulation. And then you go to flow state. Keep a mixer. Take a material stream. Take a material stream out. So give a stream input. Say you have 25 degrees centigrade, 1 bar pressure, 1 kilomole per hour. So you have specified it, and you can do the simulation. Oh, you have to send block. Okay, fine. Now you can do the simulation. Okay. Yeah. So you can do the simulation. Now, suppose you want to do send a same stream or similar stream twice. So you do not want to define another stream, you want to duplicate that stream. And so suppose you want to hit it here, over here. Okay, so this also you want to, without disturbing this line, you want to duplicate. So you just go to manipulator, put a duplicator over here, and then take it out, put it over here. And then like that. Okay. So
Okay.
now it is duplicated. Now you have to obviously give a the temperature you want from 25 to 50. Okay. Pressure you can keep at 1 bar. And now you run the simulation once again. So in S2, you will see the result in the stream S2 and S4, right? You have S2 and
Right.
S5, sorry, S2 and
S5.
S5. S2, there will be no change in the temperature, it's just a mixer, but S5, you have said 50, okay? So here you have put output 50, so you will get 50. But, and your S3 and S4, they will be same as S1 because it has been duplicated. So you can see the, what are the S1, S3 and S4, right? So S1, S3 and suppose S4. Yeah. So see, each and everything is same in this tree.
Okay.
Okay. So this has been duplicated. Okay.
And yes, sir. Thank you. And in
Yeah.
the and third question is that will be there more than one answers in the practical exam,
No,
like we
no.
see in these assignments?
Which
No,
assignment?
only one answer. In some
Uh,
assignment, there are more than one answers.
I mean, A, B, C, D, multiple
Yes,
choice.
yes, multiple
Yeah,
choice. Yes.
there may be, there may be more than one answer. You have to be
Okay,
careful.
but okay. And also, I want to know about the fractional distillation system simulation.
Fractional distillation means it comes in the advance. So you want to learn this one, right?
Yes, yes.
This comes under the advanced case. I will definitely take some course on that, but these are all advanced. So you have to wait for my next course, which will run on next July. That will be Aspen Advanced.
Okay. So that will cover HYSYS also?
No, no. HYSYS will be completely different because
Okay.
HYSYS itself is a big thing. I mean, HYSYS, I do not think I can cover in 30 lectures. For that, I have to take again HYSYS 1, HYSYS 2, like that.
But sir, in basic, how many lectures are there?
30 lectures, 30 hours.
30 lectures. Okay. Thank you.
Okay, Arun Sudarshan is saying, sir, is it possible to provide more questions other than assignment questions so that we can try and solve it and same can be discussed in problems? Assignments have already been done. Okay, so it has already been given. So I really cannot. for making new questions, I have to put extra effort for that. So it can be done one-to-one, not in the forum. I can suggest you some practice books. Okay, that much I can do. Yes. Well, Aspen books, I will give you a list. Okay, you just write an email to me at p.sha@iitg.ac.in. I will suggest you some books. And those books are available everywhere. Even if you search the internet, you will get those books. I mean, what they do, they have picked up a few practical problems and they have solved it. So you do not expect any exercise kind of books. Okay, you do not expect that one book will have 10 problems to solve and not like that. So they have, in fact, if you go to week 10, you will come across a book that I also have referred, and that is for distillation and absorption. I have referred that book and I have tried to solve the problem in that. So like that, I can send you the books if you are interested.
Sir, I also want some problem book where real practical problems are given in example. I also
No, that's what
came to know that.
yeah, that's what I'm saying. That's what I'm saying.
Yeah.
I mean, you will not expect they will give you, say, 10 problems or 15 problems per chapter for you to solve. It is not that way. They will take a industrial example and then they will try to solve in Aspen. So one problem itself will cover, say, half of the book, something like that. So that's how they do it. I mean, there is no such thing that, you know, it's not a textbook approach. Probably what you are looking for a textbook approach, that there will be a description of a chapter, and at the end of the chapter, there will be a set of problems to solve. Okay, you won't get that kind of. Yes.
So actually, what I want to know that there are various unit operations in our chemical engineering, in which
Right.
there are some problems given, and we can evaluate the answer from that, and based on that we can utilize the skills to solve the problem. So I want that much of confidence,
Yeah,
from examples.
that's what I'm saying. To begin with, you can start with problems of Richardson, Coulson, and the very common
Yes.
books like McCabe Smith or Treble. You can take up the problems from there and try to solve it through Aspen. Okay, so these are the most common source of chemical engineering problems that you can solve. Unless you want to go for a more complicated stuff, like there will be recycle stream, there will be losses, there will be pressure drop, etc., etc., etc. For that, yeah, you need some kind of practical approach, practice-oriented problem that I was referring to. Arun Singh, sir, my college is providing the problems using Aveva Pro 2 simulation. Can I do those problems in Aspen? I do not know Aveva Pro 2. Pro 2 is there. Is it called Aveva Pro 2? I do not know. There is something called Pro 2. I don't know whether it is same as Aveva. Yes, sir. Pro 2. Okay. Pro 2, yes. Pro 2 is one software. HYSYS, one software. Unisim, other software. There are ChemCAD. and Aspen definitely. So each and every software has its own pros and cons, and though the problems are not similar, the software specific problems are problems. The industrial problems, you can use any software that you. There are some free softwares available also. They will not be so much what do I say, comprehensive, but there are some free softwares like DWSeam and all. That also one can use if they need. But as far as solution of the problem is concerned, yes, any kind of steady state problem you can solve with Aspen Plus. So be it from Pro 2 or something else, doesn't matter. If your college has procured Pro 2, Pro 2 is also not a free software, it is a paid software. So your college must have purchased it and you are learning from them. Definitely, you can do it and you can try to solve those problems in Aspen.
So is there any course where I can learn the designing of various equipments which are used in chemical engineering, like heater, heat exchangers, reactors? Can we have any course for that?
You have to start MOOCs NPTEL. I think there are a lot of courses in MOOCs NPTEL. You have to look for such courses. Yeah, design courses are there. I'm sure there will be some good courses.
Does NPTEL provide these courses training?
Yeah, definitely. There should be some MOOC course on that.
Okay.
There should be some MOOC course. Okay, Arun Singh again asking, sir, can you suggest any major project aspect using Aspen? My college, they gave advice to use the simulation for major project. Yeah, major project I give to my students who are studying in IIT Guwahati. They do BTech projects or MTech projects, they use Aspen for that. But that is limited to our own students. I mean, because for major project, I have to spend time with the concerned person who will work with me in that project. So it becomes a whole project, whole 1 year project. Okay. Like topics means topics may be anything from ammonia production plant, or maybe some distillation, some amine absorption, CO2 absorption in amine, or it may be heat exchanger network, something. It's not any. It's not limited to any small area. It can be anything. Arun, probably you can unmute and talk because you're typing. Can I get the reference? Reference for what? You can unmute and you can talk, Arun, if you are not, because you're typing for such a long time.
Hello, yes, sir. Hello.
Yes, Arun, yeah.
Sir, in my college, they advised to use the simulation for the major project this time. So, can I get any reference, sir? How we can do a project, major project using Aspen?
You are a BTech student, right?
Yes, sir. BTech final year.
BTech
Hyderabad.
final years.
JNT Hyderabad.
Okay.
This year
Okay.
they introduced the simulation Pro 2. So they are telling to So they are telling to use the simulation to do major project expert.
So you must be having some project guide, right? Any of your
Yes,
professors will, yeah. So you have to ask your professor to give a project.
My
He will give a project, maybe he will ask you to some project like say CO2 absorption in mixture of amine. Okay, so there may be, or CO2 sequestration. So there will be one absorption column, one desorption column, and there will be a recycle loop. There will be several heaters or coolers associated with that. There will be some pump.
Sir, my faculty sir suggested me to go to the guides of many of the IIT students and NIT students are doing the projects using Aspen. My faculties are told to go through their websites and collect and refer how they did the projects. So I am asking, sir.
No, that's not. I mean, these are the supervision, or these are the advices they should give.
Sir,
they should give the advice.
Is IIT students will be uploading their projects anywhere?
Right? No, it is not allowed to upload the project.
Okay, sir.
If you want, you can come to IIT and you can refer them in our library.
Okay, sir. Through online mode, we cannot refer them.
No.
Okay, sir. Okay, sir. Thank you.
Okay. Okay, any more questions? MV Shattamurthy is here.
Yes, sir. I mean, I don't have any questions, sir.
Okay. Thanks for coming. Anyway, if you do not have any other question, probably we can end this session. Yes, Bablu, do you want to ask any question?
No, sir.
Oh,
No. Sure, sir. We can end.
Okay. So, Injaman, you can end the session. NPTEL?
Yes, sir. You can end
Yes.
the session.
You can end this session. Okay.
Okay.